Thanks, Jim, and welcome to all our viewers. Today I'm going to be presenting a webinar on the ABB Arc Flash Protection Portfolio, and this is part two or a continuation of a previous webinar that I did last year. This time we're going to focus on how to install the sensors for the RE Arc Flash system, and also look at how the Arc Flash relays are modeled in the EasyPower software, and look at the results of an Arc Flash study. Most of the information we'll review from part one. If you want to learn more about price and feature comparisons and more of an extensive tutorial, certainly encourage watching the part one, which is available on the website. So with that, let's begin. Let's start with a basic overview. Of course, we'll talk about, just in general this time, what Arc Flash is, obviously how serious it can be, and obviously the most important thing to mitigate it, which is the fast clearing times of the relay. Like before, we'll introduce the Arc Flash products and highlight the features and innovations. We'll briefly go over the product offering and descriptions. And then for this part two of the webinar, we'll look at how the fiber optic loop sensors are actually installed in our switchgear, this example being the SafeGear, which has a lot of other tremendous benefits that I'll mention, even though it's not the primary focus of the webinar. We'll look at some application examples and learn how easy it is to actually configure the RE Arc Flash protection system. And after that, we'll go ahead and model the RE Arc Flash system in the EasyPower software and take a look at the results of an Arc Flash study. We'll superimpose the RE Arc Flash system right on the EasyPower one line, and I think it'll be very clear how the selectivity is accomplished and how the modeling is set up in the software. Also, to conclude, we'll talk about our ReliOn line of relays, and where you have the Arc Flash option built in, and you have the standard pre-configurations and order-coded generated drawings already completed for you based on order code selection. So let's start. What is an Arc Flash? It's the rapid release of incident energy due to an arcing fault, errors the conductor. This is basically the way we measure it is incident energy, and it's caused by an object being too close to a conductor or an insulation breakdown. So that's kind of just a basic idea of what Arc Flash is, and it's something that's very, very serious. And it happens often enough, and every company I've ever worked at, there's been injuries and fatalities, and statistically it's occurring much more often than it should. So that's where we start. And here's a video actually showing just how dangerous Arc Flash can be. So as you can see, it's pretty catastrophic, and hopefully today you'll have confidence that our products are among the top technology, and because they're very easy to configure and economical, that this is a very wise choice to make, whether it's a dedicated Arc Flash system like the REA, or the built-in Arc Flash in our ReliOn line of relays, or in our new digital safe switchgear. All these are great options, and definitely Arc Flash should be included just to mitigate some of the catastrophes that are so prevalent in our business. So anyway, the main strategy is fast clearing times. That's absolutely what's critical. And you can see here that in half a second we have serious personal injuries, we have extensive damage, and actually it looks like it occurs a little bit before that based on this slide. It's 100 milliseconds, where you can get into a little bit of damage. Now, of course, if that arcing fault current is high enough, you're going to have damage at that time as well. So when you look at the average time it takes a breaker to operate, 3 to 5 cycles, or 50 to 83 milliseconds, okay, you're pretty close to this 100 milliseconds already. You don't have a lot of time for the arc flash relay to operate and quench the arc. So time is of the essence, time is critical, and that's what we offer. So you can see here the operating time is very fast. This is 0.086 milliseconds. It's negligible compared to the breaker time, which is 5 cycles here, or 0.083 milliseconds. So you can see that it's the fastest operating time that you can have. Our ReliOn is very close. We're somewhere between the first and second column for the built-in arc flash feature ReliOn, the function of ReliOn. Depending on the measurement mode, whether it's RMS or DFT, it'll be just a little bit slower, but not that much slower. So it's still a pretty good choice. The advantage with the REA, of course, is you have loop sensors instead of lens sensors. And if the fault current's high enough, you know, depending on the situation, you may want to go with the REA. I think the REA is the best way, just because of the sensing. But ReliOn is a pretty good choice too, to have it built in. So you're certainly going to have a lot more protection than if you didn't have arc flash protection at all. So you can see here in the green, that's below hazard category level 3, and so it takes quite a bit of fault current before you start getting into the higher danger zones. And you can see here also that it depends on the grounding and the equipment type. So ultimately, though, you're looking at speed. That's really the main driver. And so if you don't have an arc flash system, whether it's dedicated or built into a relay, then there's definitely a risk. Time over current relays are too slow. You can see here that, you know, I drew kind of an arbitrary danger line, say 100 milliseconds. Your REA operates below that, whether it's a 3 or 5 cycle breaker. It operates fast enough to where you're going to avoid damage even at those high arcing currents. The differential is extremely fast, but it's still, you can still have a little bit of damage instantaneous, even more so. And time over current is just that's just really, to me, not an acceptable arc flash solution. You're going to have considerable damage and jeopardize personnel safety. So there's the basically the difference, the relative difference in speeds. So obviously the REA arc flash system or any arc flash system is the way to go. And just to kind of, I guess we'll get into another slide, but we have a very fast instantaneous element for our high stage, which is 20 milliseconds, but it's still, relatively speaking, quite a bit slower than the arc flash system. So even though your fastest instantaneous relays out there, you still run the risk of severe arc flash hazards. So let's take a look at just how fast the REA arc flash is compared to a traditional instantaneous relay operating for a half second, which is the IEEE standard for testing. So we'll run the video and we'll show you that you know, the standard is to contain the explosion and to prevent a fire for a half a second 3-phase voltage arc flash. So you can see the significant difference that the operating time of the REA makes compared to traditional relay. So this is 5 times slow motion. So you can see, you know, it's a pretty serious condition on the left. You know, you didn't have the fire, you contained the explosion, but just visually you can see just how much the explosion potential is reduced by having an REA arc flash relay that can operate less than 2.5 milliseconds, which is just not much more than 1/10 of a cycle. So it's very fast and very effective. Okay, so now let's introduce the arc flash protection solutions that we have. And I probably should have started with this in the beginning, like last time's webinar, but I wanted to really make everyone understand just how serious arc flash can be and how important the clearing times are. And so now here are the products that provide those clearing times. To the left we have the REA arc flash protection system, the main unit, and then 3 extension units. And we have the ReliOn family of IDs where the arc flash function is built into the relay, and both are very fast. The main features of the REA arc flash system obviously is speed. Now it operates at the speed of light. It's certainly among the fastest out there, if not the fastest out there, less than 2.5 milliseconds. And the solid state tripping elements use the insulated gate bipolar transistors. So because it operates so fast, obviously you're protecting personnel and equipment damage, and that's the main takeaway here. And certainly I challenge anyone to find out if there's arc flash systems that can operate faster than that. And keep in mind, this is the detection of the light for the arc, and also the current, and then to close the contact and issue a trip to the breaker. So it takes that amount of time to issue a trip to the breaker, and then which is negligible compared to that breaker time because it's so small. You have the loop sensors. You can sense they can sense light throughout their entire length. It can be as long as 60 meters. You have supervision for the sensors, which is very important. You also have supervision for all the different connections between the modules as well. So having a supervised system is obviously it provides a lot of security. With our extension units, you even have selectivity, so you can divide the protected area into sub-areas and maintain continuity of power to your customers better. And they're very easy to use. And we're going to go through some examples on how to set the dip switches for different applications and what the guidelines are for the different applications. So the main takeaway here with this slide is, one, it's very, very, very fast technology, and 2, it's extremely easy to use. So that, with the fact that it's economical and a lot of other things, hopefully customers will realize the benefit of using an arc flash system. Of course, the fastest arc flash possible is where you don't have to depend on the breaker. So if you look at the 2.5 milliseconds that the REA can operate in, and you use an ultra-fast earthing switch, then you can create switch the arcing fault to, you can create a 3-phase to line, or a 3-line to ground arcing fault, and then the current limiting fuses will blow, and that quenches the arc. So this is less than 4 milliseconds after detection, and it's by far the fastest way to eliminate an arc. There's essentially no damage whatsoever when things operate that fast. As a matter of fact, during testing, human testing, the copper wire they used to create the 3-phase to ground fault, it didn't even melt completely before the REA arc flash system quenched the arc. So just to give you an idea how fast that is. And of course, the only downside to that is replacing the current limiting fuses, and you're putting a fault on your system. But with that amount of time, it's such a fast clearing time that it's not really a significant issue. Okay, now we're going to switch to our other product that has the arc flash function built in, which is ReliOn. And so here you have with the optional communication module that has the arc flash sensors, which are lens sensors. So that's not doesn't quite offer the same coverage that the loop sensors do. So that's could be considered one slight drawback. The other is that the speed is not quite as fast, but like we discussed before, it's not much slower, and for all practical purposes, you're offering the same protection that you would with the REA. So that's basically the idea there. Since speed is very important and you're losing a little bit of speed anyway, it's best to order this product with the high-speed output, so it's just 1 millisecond for the high-speed outputs. And also when you get ReliOn, you get a lot of things other than the built-in arc flash feature. You get the advanced technology that we have in our switch gears now and our customers are using, mainly the easy to implement native IEC 61A50 protocol and the flexibility of the relays. That's so basically you get a lot for, there's a lot of other things that you get when you use ReliOn relays. So that's certainly a good solution for arc flash. Now we're going to compare the technologies, and I've already done this to quite a degree already, but just to actually get some numbers out there, you can see that over here for traditional relaying, and this looks like it could be a differential relaying, maybe a very high, fast instantaneous relay, 25 milliseconds. It's just current, not light. That's an order of magnitude of about a cycle slower. So if the arcing current's high enough, you can get into some danger. Like I stated before, we have an instance 3 of our high stage protection that is 20 milliseconds. So if you have the high speed contact of 1 millisecond, then you're just under this 25 milliseconds. So even with our fastest technology, you're still a good cycle or more slower than the arc flash, the dedicated arc flash solutions. For ReliOn, you can see that now you're cutting this in half. It's depending on the measurement mode, you can even cut it down a lot more towards just only twice as it takes twice the time to operate than the REA. So really, when you look at it, you got the 25 cut in half with DOT measurement mode, and then cut in half again with peak to peak. Even though it's not as accurate, it's now you're starting to get very fast. And then the conventional or the REA is of course the very fastest. With the ultra fast earthing switch, you have to depend on the breaker. So that's all of your times here, and these times are basically what we're going to use to model the response times in the EasyPower arc flash study. So now let's briefly go over the RA family and kind of see what they look like and discuss some of the main features. You have a main unit, which is the RA101, and that provides all the tripping. You have the extension units, the RA103, 105, and 107. The RA105 also has high-speed tripping units, and so it can provide selectivity. That's the main takeaway for the RA105. The RA107 just has lens sensors, and the RA103 has the loop sensors, but it has to pass the light information back to the main unit, so you don't have your selectivity. Here's the main unit. It functions as the master. It has the CT input, so you can either have two-phase, three-phase, or two-phase and ground. You can use a zero sequence or CT or residual. You have one fiber optic loop sensor. You have two high-speed tripping outputs. You also have a third output that's standard. You can use those for breaker failure as well. You have an opto link that connects the two to transmit and receive current information or trip information or light. We already talked about breaker failure protection, and you can connect them to the extension units via RJ45. You connect up to two groups of 5 extension units. Here's the front panel. You have a power light. Here's your the status, the current light and trip. You have a relay failure, which also can be controlled by a binary input. You can supervise the loop sensor. You can supervise that everything that's connected to that main unit, namely the opto links, the ports. You can reset the targets. You also have a backlight compensation setting right here to avoid nuisance trips. And you have a trip key switch, which is light or lighting current. And if you're using breaker failure, you need light and current. So I'm probably getting ahead of myself there. We'll see that in another slide when we set up breaker failure. And then you have the dip switch settings down here. So everything is controlled with dip switch settings. They're very easy to understand, and you don't have to communicate with these devices. They communicate with each other, but it really comes down to just making some basic decisions regarding your application, and then you can set the switches accordingly. Here are those switches. A lot of information here, but ultimately it can be just broken down into a few areas. You have your pickup for phase and ground. You can set the magnitudes on per unit of the nominal. For ground, you also have to enable the ground. And then you have the backlight compensation. You can activate the sensor and the other things that are connected to it, like the ports, the opto links, and you can also determine what you want to transmit, what you want to receive, either the current pickup or the light or the trip on these opto links. And then you can program your delay for the contacts that you want to use for breaker failure. So that's basically the common theme for all of these RFlash REA products. Here's a look at the back panel. Tripping outputs, 2 high-speed, 1 standard. A relay failure alarm. Here you can daisy chain your extension units, 2 groups of 5. You have a fiber sensor port for your loop sensor. Here's your opto links. And then you got control power, your standard 24, 48, 120 volt DC, and also your AC control power. Your external reset when you want to use a binary input to reset, and then all of your current transformer, your CT inputs, which can either be the 1 amp or the 5 amp nominal. This is a connection diagram for the main unit. There's connection diagrams for the extension units as well. We won't show those this time. This is very helpful as a troubleshooting tool. It can also help you predict how the system's going to behave. It tells you how the CTs can be connected. If you want to use ground, you can use a 0 sequence. You can use the residual, or you can just have 3 phases. You can have a 1 amp or a 5 amp nominal. It shows all the switch settings here, which is helpful because it can tell you what information is passed back and forth between the main units or the main unit and the extension units. Now let's look at the RE103. That's an extension unit, and its main purpose in life is to be able to provide additional coverage, and all it does is detect light and sends it back to the main unit, and if the magnitude of currents exceed the fault detector, you're going to go ahead and trip the breaker. So you don't have selectivity, but you do have added coverage. Comes with 2 alarm contacts, and of course you can daisy chain 2 groups of 5 from the main unit. This is what it looks like, and here are the switches. You have the switch 1 is for termination. You can have 5 daisy chains, so the last one has to get terminated. That switch would be on. You have backlight compensation. You can turn that on if you want, and then you can activate your sensors. It has 2 loop sensors, and then you can have you can supervise those loops. So the default is deactivation off. So basically that means it's being supervised. So unless you don't want to supervise it, then you would turn that switch on. So if you have radial sensing, then you can't supervise. You have to have a loop to supervise. Now let's go to the RA105 features. Now we'll look at the RA105 front panel, and you have your termination switches for terminating the last extension unit in the daisy chain. Backlight compensation, you can activate the sensor. Light to port input 1, what that is that you can use input, the light from input 1 to send back to the main unit. In that way it can act basically like an RA103. Generally that application is not used. You always have this switched off, and then you can have breaker failure. You can delay the light signal back to the main if you have a breaker failure. So the idea here is that you want to achieve selectivity, so you don't want to send light back to the main unit. You do want some discrimination for downstream marking faults. Then you have your pre-programmed breaker failure delay, and you have your loop supervision. Now let's look at the RE107 that has 8 lens type sensors, and it acts the same way the RE103 does. You can daisy chain all these and send light back to the main unit. If the main unit fault detector picks up, then you're going to trip the main breaker. So just once again, it provides additional coverage, but you don't have the loop sensors. You need to rely on the lens sensors. Here's the front panel. You have your termination for the last one in the daisy chain, your backlight compensation, and then you can activate all the sensors for the remaining switches. Now let's take a look at the optical fiber sensors. They're very long, can range from 5 meters to 60 meters. And you can have a splice to get that extra length. Here are your lens sensors. They can range from 1.5 meters to 30 meters. They're used with the RA107. Now we'll talk about we'll look at the OptoLink communication fibers. They range from 1 to 40 meters, and they're for connecting between the main units for transmit and receive current, light, and trip signals. The main units voltage has to be at the same level for the communication to work properly. Here's our RJ45 cables for daisy chaining the extension units. Lengths range from 1 to 40 meters. And here's our shipping split adapters. So when you ship the switchgear in 2 parts, then you can connect these cables at the junction point. Now let's take a look at how we're going to install these. Right here are pictures that you see from our newest switchgear line called SafeGear, which is an arc-resistant design. There's also many other benefits to this switchgear, and it was just displayed at the Automation Customer World Trade Show in Houston. You have the IEC 61850. You have the sensor technology, and there's a lot of other things, and it's certainly beyond the scope of this webinar. But if you ever have a chance, check that out. Not only do you get the built-in RA arc flash system already installed up to the shipping split, there's also a lot of other tremendous benefits to using SafeGear, and obviously, the arc resistance and the fact that it's very flexible and safe. Safe is the main thing. You have the CTs don't saturate. You don't have the risk of an open CT. You don't have ferro resonance with the PT. So there's certainly, when you're talking about safety, you're talking about arc flash. You also have to talk about SafeGear and the sensor technology. So basically all that comes along in the package, and the other part is that you don't have to worry about the installation. There's a complete manual. Everything is done for you. You just have to connect it at the shipping split. So you can see here that this is how the fiber loop runs. You have the skeleton clamps, and you can see the fiber right here being protecting the bus bar, and this is how it's routed throughout the switchgear. Here are your side terminations at this shipping split, and once again there's a manual that just a few pages and kind of guides you through this step by step. You cut the wire ties, run them through to the next cubicle, and you already have these tie wraps supports in place, and then it's just a matter of connecting the cables together. And this is the complete, the finished product. So you already have the arc flash, the REA arc flash installed, and so that's just one benefit of using the SafeGear. Now let's look at some application examples, and just to show you how easy it is to set. And there's only a few objectives that you need to keep in mind. One is obviously you have to minimize the incident energy, and that's done with fast tripping. That's certainly what the REA arc flash and the ReliOn arc flash function is all about, and the high-speed outputs and the ultra-fast earthing switch. Everything is about speed. And then, so then you want to optimize utilization of the power system. That's also has to be a chief objective of the engineer. So that's where the selective tripping comes into play. You certainly don't want to take out as little of your system for an arc flash event as possible. And then safety is certainly a big issue. The first one is about safety and damage, but evaluating the instant energy for breaker failure is also very important, and that contingency needs to be looked at. Even though arc flash is very fast, you can't always rely on the breaker. So you have to ask yourself, if we put 100 millisecond delay in there or something like that, or the choices that you have on the dip switch is, how much is your arcing current, how much instant energy are you going to add to the system? So that always has to be a consideration. Now let's take a look at some examples, and we'll show you how easy it is to configure the switches. Right here you have a main transformer connected to a single bus, and you're using an REA 101 main extension unit to provide the arc flash protection. You can see here you got two phases connected to it, and the zero sequence CT for the ground. You're tripping Q2. We're set up for breaker failure to trip Q1. We have a lens sensor that's protecting the bus, the breaker, and the terminations. So if you were to have an arcing fault in the zone of protection, and what would happen is once the current level, it's just a minimum value, is picked up, and you have light and current, then you would issue a trip from the high speed output. That's your 2.5 milliseconds, and then the breaker would trip. If the breaker did not trip, then you have that pre-programmed delay that results in high speed output 2 tripping Q1. So let's see how we set the dip switches here. Here's M1, which is the main unit. That's all we have here. We're going to set a 1 amp pickup and per unit of the nominal. Don't need backlight compensation in this case. We're going to activate the sensor, and the ports are off. We're not connecting any extension units, so both of those are off. We're also not connecting an opto link to pass current or trip or light information, so this is not applicable either. Now for setting group 3, that's the breaker failure. We're going to use breaker failure, so it's important to have the current and light switch to the current light position. We're going to use high-speed output 2 for breaker failure. We're going to set it at 100 milliseconds, and we're going to supervise the loop. For the ground, we're setting that to about a third with the dip switches, and then switch 5 has to be on to let the unit know that we're also measuring and using ground fault current. Now let's look at another example. Same as before, pretty much. Protecting transformer, a single bus. Here, what we're going to do is use extension units now, and we're going to use the RA103 that not have the selectivity here, and then on this portion of the bus, we'll use the RA105, which does provide the selectivity. So you have the loop sensor that wraps around the bus for the main, and then the RA105 extension units are protecting the feeders. And then for the RE103, that protects the bus breakers and terminations. There is no selectivity. If you have an arcing fault, then that light information is passed back to the main unit, and if you detect if the current exceeds the fault detector level that you set it at, then you're going to trip the entire bus, no selectivity. If you have an arcing fault either on Q3 or Q4, then what's going to happen is you're going to, if you have an arcing fault on 3 or 4, if the current exceeds the fault detector value, and it almost certainly will, that current information is passed to the RA105. So when it sees that arcing fault, it's going to trip its own dedicated high-speed output contact, and that's the only feeder that's going to be taken out of, or that's going to be removed from the system, so you've achieved your selectivity. So let's take a look at how the dip switches are set. The same as before on the pickup, and then no backlight compensation. You're activating your sensor, and once again we're not, now we're using the port A and B for our extension units, so these will be on. Otherwise it's the same as before. We're now connecting to another main unit, so we don't have to worry about the settings for the optolinks. We look at setting group 3, that's our breaker failure. We're going to, on the main, we will have breaker failure for Q2, set at 100 milliseconds and supervise the loop. In this case, we're not using the ground, so we'll turn that off, and so these settings don't apply. Now let's look at the REA103 extension units, which provide the coverage but not the selectivity. You'll terminate the last one in the string, which happens to be S2, last one in the string. And then you activate your sensors, your backlight compensation, and then your supervision. So that's pretty basic. Let's look at our RA105. You're going to terminate terminate S3. S3 is the last one in the string, so you'll terminate that. Here it looks like we're using backlight compensation. You're activating your sensors. Light to port input 1 is off, so we don't want to send light back to the main unit. We want selectivity. That switch is, for all practical purposes, always off when you're using the RE105. And you have a delay of light back to the main unit of 150 milliseconds in the event that you have a breaker failure on either one of these feeders, either one of these breakers, Q3 or Q4. Now we're going to look at an example where we're using the optolinks, and this is for a main scheme, and in the event that you're single sourcing, you need to transmit the current from one main unit to the other, so the current information can be passed to the RE105, so when it detects an arcing fault, it can provide trip through the high-speed speed outputs, which makes it selective. Otherwise, it's the same as that we've seen in example 2. So we're going to take a look at the switch settings. 1 amp per unit of the nominal. We're using backlight compensation this time. Sensors activated. This time we're just using port A. So we'll have that switch on. Port B is off. We're using the OptoLink this time, so we'll have the switch on for the main 1, which means that we're receiving current, and we're transmitting current here on X10 for OptoLink 2. We're now using breaker failure for Q1, and we are supervising the loop. We're not using the ground, so that's turned off. For main 2, same thing, 1 amp per unit nominal, using backlight compensation, activating the sensor, and we're not using any extension, we're not connecting any extension units to main 2. The OptoLinks we are using in conjunction with main 1, so here it's going to be just the opposite of what main 1 was. We're going to transmit on X8 on OptoLink 1, and we're going to receive on OptoLink 2, which is X11. We're going to pass that current information back and forth. So when you see that fault detector level, then the RA105 is going to receive that information, and as long as there's light detection, it'll trip its dedicated output and provide the selectivity. So here's the now for the breaker failure, we're not going to use that on M2 either. And we'll activate the, we'll have the sensor supervision. We're not going to use the ground. So for the RA105 extension units, we'll terminate the last one in the string, which is S1. Backlight compensation, the sensor will activate. Here we're going to have light to port input 1 on, and the reason being is because if we want something that's ultra safe, normally you have this selectivity, but what happens if you have a breaker failure? Now what's going to happen is you're going to have a delay before you trip Q2. So if somebody's exposed there, you're going to have another, you're going to have some buildup of incident energy from that additional 100 milliseconds. And so it's something to keep in mind that, you know, if at the expense of having breaker failure, you have more incident energy. So, you know, if safety always should be the priority, and this is a case where this switch is available, so you can, it can act like an RE103, and you can send light back to the main unit, and if the fault detector is picked up, then you're going to trip Q2, so you're not going to have that added incident energy that's a result of having that selectivity in the event of a breaker failure. So that's just to let you know that that option is out there. Typically the switch is turned to off, and then you would delay the light signal back to the main to provide breaker failure protection in the event that either Q6 or Q7 fail. Now we're going to talk about how to model the RA arc flash system in the EasyPower software. And here you can see an EasyPower 1 line that was created. And this is how the RA arc flash system, which consists of a main unit, RA101, and 3 RA105 extension units connected to it, look when it's superimposed on this one line. So you can see you have a CT for the main unit. It just requires a minimum amount of current so you don't have spurious trips, and that information is received by the main unit. You have an RJ45 cable that is daisy chained to all the extension units, and that's how the current information is passed to the extension units. They have to get their current information from the main, but they have dedicated sensors that are protecting each bus. So if you have an arc flash event, like we talked about before, you get the light information, and then the current information is passed from the REA 101, and then it'll trip its own dedicated high-speed output contact after 2.5 milliseconds to operate this breaker and quench the arc flash fault, making the protection selective. And that's what these blue lines here are, high-speed outputs. They operate very quickly. The detection and the operation of the contacts is less than 2.5 milliseconds, which is not much more than 1/10 of a cycle. So very fast. So that's really kind of what it looks like superimposed. You got to have your current, you got to daisy chain them, and you've got your sensors. This is the way we modeled it. You've seen this in a previous slide showing the range of all the times for a standard 3 to 5 cycle breaker. And for the REA, it's very fast, 2.5 milliseconds. That gets tacked onto the breaker time. And we looked at a 3 cycle breaker, so that information is provided in the arc flash hazard predefined time for the arc flash unit. And then we can run an arc flash study and take a look at the results and see what the incident energy line looks like. There is no graded protection here like overcurrent coordination. Everything operates super fast. What provides the selectivity is the dedicated sensor loops. So you can see here that you've got the the high-speed output, the dedicated high-speed output contacts. That's what provides the selectivity. So if you have a bus fault, then or an arcing fault on the bus, then you're gonna satisfy the light condition, and then the minimum current is passed down to the unit, so it protects. So it uses its dedicated high-speed output contact to trip just this breaker, for example, and the rest of the system is intact. So everything is responding as fast as possible for arcing faults, but the selectivity is through the dedicated high-speed output contacts and sensors for each REA 105 extension device. The incident energy here is 3 calories per centimeter squared for both the main switchgear and all the buses. And that's for the operate time that you saw on the previous slide of 0.0525 seconds or 0.05 or 52.5 milliseconds. So once we run the arc flash study, then you can see the arc flash report. And we ran the arc flash study, looked at all the devices. Here's the incident energy for the REA devices, the main and switchgear and the 3 buses. And here's the arcing time, which consists of how long it takes the REA to operate and the breaker time collectively. And that information is provided here, and you can see the resultant incident energy. It's a hazard risk category of 1, which is formerly what it was called. Now it's a calorie rating. So, but the idea here is that hazard risk category 1 is a very low, very safe rating. So that's what we're trying to achieve. You can see here with the other devices, you have a differential, you have overcurrent devices, and you can see here that the incident energy is much higher, and you're into the category 2, 3, and 4. So you can see here that this isn't ideal, and we talked about before, overcurrent relays are too slow, and to provide the best possible protection for our personnel and prevent damage, having an arc flash system is absolutely essential. Now let's take a look at the ReliOn family. We already talked about the REA and all its capabilities, and we briefly touched on ReliOn. You know, we have a complete line of distribution and transmission products generation. EasyPower has modeled all the standard overcurrent curves in there, and now we have the arc flash protection modeled. And we can use these also, use the built-in arc flash feature that's already in the relay, which from what we've seen before is offering, for all practical purposes, the same amount of arc flash protection using the lens sensors. So in order to get the right relay, you have to have the arc flash option, or have the right communication module selected that has the arc flash detectors on that card. That's what that is. And then the other order code option that's vital is having the high-speed outputs. You need to select an option that gives you the high-speed outputs. You know, because even an additional 10 milliseconds can make quite a difference. So, you know, that's definitely for a small additional price. If you're going to use arc flash, then you need to use high speed outputs, and all of our default logic is set up such that you are using the high speed outputs, and you have the pre-configured logic for your arc flash detection system, as you can see here, arc flash detection. So you don't have to configure any of the logic. Everything is already programmed for you, as long as you select the right relay. And also you have a complete set of drawings based on that selection. So this is a project I've worked on where you can enter the order code of any of our ReliOn relays, and then you can generate a set of drawings. So I'll just click on this even though it doesn't work. See, now it works, okay. But this actually, I have a tool where you can click on that command button and it generates automatically any one of like 7,000 drawings. So you can see here is your arc flash, and you got your lens sensors, and then over on the other side it's programmed to your master trip and your output contact. So, and also your high-speed outputs, your arc flash is programmed to your high-speed outputs. So everything's pretty much done for you. You know, this is the FT1 arrangement. You can see here your arc flash. So everything is already pre-designed, pre-configured. It's built in. So it's very easy to use. Here's your high-speed outputs for that particular order code. It's order code option D1 gives you the high-speed outputs. And F is the communication module that gives you the communication that has the arc flash detectors. And so this is of course just a connection diagram based on our FT1 arrangement in our AC and DC schematics. So if you were to use ReliOn, you can use it in conjunction with an REA. You have your lens sensors for the ReliOn products, and so you can, you know, with the dedicated high-speed outputs, you can sense light through the lens detectors and provide selectivity for the feeders. ReliOn has a 12-year warranty. I believe that's the best out there, but don't quote me on it. And that concludes our presentation. I'd like to add that you know, we do have some literature that we'll have available for the ultra-fast earthing switch. Jim mentioned that he believes you would like to learn more about that, and customers would benefit from looking at that. We also have some information on our SafeGear to show you step by step how easy it is to make these connections for the shipping split, and also to reiterate the SafeGear has the sensor technology and arc resistant, so it's very, very safe, and that's certainly critical in this business. Next year, this is part 2, hopefully there'll be a part 3, and when the SafeGear returns from the, well, it's probably already returning from our big trade show in Houston, which is Automation Customer World, what I can do is go to our factory and make a video and show you how everything's installed. And, you know, we can look at a project with the RER class system. We can look at ReliOn. We can see how all the curves are modeled in EasyPower, do a coordination study. So there's a lot of potential. And the main thing is to emphasize the speed, the advanced technology, and above all, hopefully what I demonstrated today is the safety. So with that, thank you so much for attending, and feel free to ask any questions either now or in the future offline. Again, thank you.